Wi-Fi clock project. Explanation for students. Narration script, English text-to-speech. Hello, students. Today we are going to learn about a smart digital clock. This clock uses the internet to always show the correct time. It is built using a small computer chip called ESP32-C3 Mini. This clock does not use a normal screen. Instead, it uses 256 tiny LED lights. These lights are arranged in a grid of 32 columns and 8 rows. This type of LED is called a NeoPixel. Each LED can glow in any color we choose. When the clock is switched on, the first thing it does is connect to Wi-Fi. Once it is connected to Wi-Fi, it contacts a time server on the internet. This process is called NTP, which means Network Time Protocol. This is how the clock always knows the exact time, without anyone setting it manually. India's standard time is 5.5 hours ahead of Greenwich time, so the clock automatically adds this difference and shows the correct Indian time on the LED grid. This clock can show information in different ways. First, it can show the hour and minute. Second, it can show the hour, minute, and second, scrolling slowly across the screen. Third, it can show today's date, scrolling from right to left. This project also has 2 extra features. The first is a temperature and humidity sensor called DHD22. This sensor tells the clock how warm the room is and how much moisture is in the air. This information is also shown scrolling on the LED grid. The second extra feature is an alarm. Students can set an alarm time using the hour and minute. When that time arrives, the clock flashes the word alarm in red, and a small buzzer makes a beeping sound, just like a real alarm clock. If the Wi-Fi connection breaks, the clock tries to reconnect automatically. Until it reconnects, the screen shows the word Wi-Fi, so we know something is wrong. The wiring for this project is simple. The NeoPixel grid's data wire connects to a pin called GPIO4. The temperature sensor connects to GPIO5. The buzzer connects to GPIO6. All the parts share a common ground connection and a 5-volt power supply. Through this project, we learn how microcontrollers, sensors, LEDs, and the internet can work together to build a useful and colorful digital clock, all by ourselves. Thank you. Arvind Patil /AI Centre Nandurbar.